So I want to use Adobe Audition here for a quick conversation about bit rate, which is how many bits per second an audio file is taking to save. So I'm going to do this by making a couple of new files. I'm going to make a new audio file. This one, I'm going to start off with one that is low quality, 6,000 sample rate. So it's only doing 6,000 samples per second. And I'm going to have a bit depth of 8. So it can only take a value between 0 and 255 for the kind of height of the wave. So if I click OK on that, and I'm going to record for a little bit. And I think a reasonable number to work with would be 5 seconds. That's about 5 seconds worth. 5 and a very little bit. And if I now was to say save as, and I save it as a wave file, wave uncompressed 8-bit integer, it tells me that that file will be 66.8 kilobytes. Remember that number. Actually, can I just take a snip of that? Good. Quick snip. And was it 66.8 kilobytes? Minimize that. Cancel. I'm not going to bother saving it because I don't need to save that file. And I'm going to make another new file, but this time my audio file is going to be a lot higher quality. It's going to be, instead of 6,000 sample rate, 6,000 dots per second, it's going to be 192,000 samples per second. And the bit depth I'm going to choose as being 24 bits. So that's actually, I think, 16 million, awful lot more positions than 8-bit, which is only 256. So each dot can take one of 16 million or more positions. So I click OK and record another 5 seconds of me narrating this video. Tumty, tumty, tumty. That's roughly a little bit over again, which is perfect. That's same each time. So now if I do a save as on this, let's just actually think about it before we undo that. So 192,000 is at, compared to 6,000, it's actually 32 times bigger. So we've got 32 times more samples per second, and the 24-bit is 3 times the 8-bit. So we're multiplying by 32, we're multiplying by 3. So actually it's 96 times bigger in theory. So if we go back to here, let's do some rough estimate stuff because I wasn't very exact about the 5 seconds. 66.8 kilobytes, multiply that by 100 times bigger, should be 6,682 kilobytes, or 6.6 megabytes. So if we do save as, see how close we are to 6.6 megabytes, 6.07 megabytes. Hey look, we're roughly in range. I'm going to call that good enough. Okay.